Hi, in this video we will learn about a popular technique called clustering and how to do it in R. So clustering, as we all know, is an unsupervised classification technique where the purpose is to group similar points which are close to each other into one cluster. Therefore, clustering involves the finding out of similarities and differences within a data set, and the purpose is to group the similar items together and form clusters. So intra-cluster similarity will be very high because items placed under a single cluster will have a high level of similarity among each other. However, if there are two clusters, they should be as different and as distinct from each other as possible. So that defines how good a clustering is. This we will learn using the k-means clustering technique in R, and for this we'll use a data set called iris. So I load the data set, data of iris, which is an inbuilt data set in R, and we have a look of how the data set is and what it comprises. So this shows the sepal length, sepal width, the petal length and the petal width of a few species of flowers, and the dependent variable here is the species to which the unit belongs to. So there are three kinds of species of flowers which are being considered here. So the number of species in this entire data set is 3, and the number of rows here is 150. So there are 150 entries of different kinds of flowers, and based on the characteristics of their sepal length width and the petals length width, they are been classified into 3 kinds of species. So they could be either of these 3 species. So the purpose here is to classify each of these units into which of the species they fall into. So for that we'll create another data set where the species is absent. So say I1 is another data set where I1 is equal to iris. So we have a copy of the data set and we'll work with this copy so that the original data set remains undisturbed. And iris I1 species will be equal to null. So the last column of this new data set I1 has the null defined. So if we see head of I1, it will have the first 4 columns, but the 5th column is missing, which is supposed to be found out. So R has an inbuilt function known as the k-means, which uses the function of the k-means clustering algorithm and then gives the results of which is the cluster into which each of these observations can be put into. So I say result res is equal to k-means of I1, comma, the number of clusters. So because here I know that the number of species contained in this entire data set is 3, I will want to create 3 clusters. So basically all these 150 elements have to be classified and put into either of these 3 species. So I write res is equal to k means I1 comma 3, and then I see the results. So the result shows me that the k-means clustering has formed 3 clusters and the sizes are 50, 38 and 62, and they all add up to 150 elements. The cluster means have been shown by the small table. So the first cluster has a mean of sepal length as 5.006, a sepal width of 3.42, a petal length of 1.46 and a petal width of 0.24, and all the numbers can be interpreted accordingly. Now, the clustering vector shows how each of these 150 units are put into either of these 3 clusters. So if you see the first, second, third and so on up till so many units, so many observations have been put into cluster number 1. The 82nd observation belongs to the cluster number 3. These observations belong to cluster number 2 and so on. And there is also a measure known as the within cluster sum of squares by the cluster, which is formed by the amount of the sum of squares within each cluster divided by the total sum of squares. And this also, the result also shows us the value of the clusters, the centers and a few other attributes for this result. Now suppose I want to see the size of each of the clusters formed. So I write res $size will give me the size of the 3 clusters formed. So the sizes are 50, 38 and 62. Now if I want to see the clusters which are formed, I can write res $clusters cluster, and I see that the result is as below. So it shows that these 150 observations have each of them classified into result number, the cluster number 1, 2 or 3. Now I want to see how good this fit has been. So how do I do that? I plot the result, say iris of C. I want to do it against petal length and petal width, so I write petal dot length, which is the name of the column, comma, petal dot width, and I color them according to the results of the cluster. So rest dollar cluster. So depending on which cluster they fall into, they will have different colors for each of them. And we see that the result has a small error, so it has to be okay. So this should not be there, and we see that the result is like this. So we see when we plot the petal length and the petal width against each other, the black, the green and the red circles show us the 3 clusters which are formed as a result of these k-means clustering. So the sizes are 50, 38 and 62 respectively. Now we want to see how good it has been in terms of the original cluster. So this is the result which we have found out of the k-means clustering. I plot the same thing by keeping the color as the one which was present in the original data set, for which I write iris dollar species, and see that the result is this. So if you see, it is not much different from what we obtained as a result of the k-means clustering, which shows that our result has been pretty good in explaining the clustering process. For this we can have another process by plotting the table of our results versus the original results. So I can write iris dollar species, which is as it is in the original data set, against the results dollar cluster, which will plot how I have obtained it as a result of the k-means exercise. Now this table shows that the species Sentosa had 50 observations, which has been clearly defined according to our k-means example also, because all the 50 units, all the 50 observations are found under the same cluster. For the second cluster, for the second species versicolor, which belongs to cluster 3, out of the 50, 2 of them have been come into the second cluster and the rest 48 are there in the third cluster. So there's a small error or a small discrepancy in terms of 2 observations. Similarly, here in case of the next species Virginica, we see out of 40, out of the total of 50 which belong to the cluster 2, 36 have been correctly specified to belong to cluster 2, but 14 have been specified to belong to cluster 3. So we see that the performance has been pretty good and the error is not too high, and therefore the k-means algorithm has been successfully been able to predict or to classify each of these 150 observations into one of these 3 species into which they fall into. Now suppose instead of the petal length and the petal width, I want to see according to the sepal length and the sepal width. So for that I plot iris C sepal dot length, comma, sepal dot width, comma, color is equal to result dollar cluster. So that is how we have obtained it to be, and we see that the clustering result is as below. So the black, the green and the red circles show how 3 of these clusters are formed. To see how they have performed against the original specification in the data set, we do it again by keeping the colors as the original data set. So color is equal to iris dollar species, which shows me this figure, which is more or less the same as what we had obtained from the previous statement. So we see that our k-means clustering algorithm has been able to classify each of these observations into one of these 3 species quite successfully. The results have been pretty good, And that is how k-means clustering can be used to classify similar objects, similar units into clusters and keeping distinct objects absolutely different. Thank you.
Hello, this is Dr. Grande. Welcome to my video on performing a k-means cluster analysis using SPSS. In counseling research, we use k-means cluster analysis to group items together based on scores across multiple dependent variables. So looking at the fictitious data I have loaded in the data view in SPSS, I have an ID variable, and let's assume that these represent programs that treat substance use disorders. So you can see they have 50 programs here in the data set, and then post-test scores for depression, anxiety, and substance use. And let's assume that the higher the score, the greater the frequency, duration, severity of the symptom. So in this situation, we could use a k-means cluster analysis to see how these programs group together based on these three scores. So the first thing I'm going to want to do is standardize these three scores. And I'm going to do that under Analyze, Descriptive Statistics, Descriptives. I'll reset this. And I'm going to move Depression, Anxiety, and Substance Use, the three dependent variables, the three post-test scores, over to Variable, and then down here you see the checkbox, Save Standardized Values as Variables. I'm going to check that and click OK. Now it has created three new variables for us, but it's interesting to take a look at this too before we go further. You see depression, we have a mean of 47.7. It has the lowest standard deviation. Anxiety has the highest mean, 55.86, and the greatest standard deviation. And then substance use, 47.68, so very close to depression. And the standard deviation is a little greater than depression, but less than anxiety. So going back to the data view, you can see all the z-scores for depression, anxiety, and substance use. So to run the k-means cluster analysis, we'll go to Analyze and Classify, and we want to select k-means cluster. This is what the dialog looks like by default. You can see that it specifies the number of clusters by default as 2, so we'll go ahead and keep 2 for now. And I'm going to move over the z-score for depression, anxiety, and substance use into the variables list box. Iterate I'm going to leave as it's set by default, which is a maximum iteration count of 10. And I will save cluster membership as a new variable for the second analysis, but I'm not going to check that off at this point. That'll create a variable that will indicate the cluster membership for each of the programs here. And then under Options, the only change I'm going to make is I'm going to add the ANOVA table. Click Continue. So it's now configured to create 2 clusters, and click OK. So you can see it provides initial cluster centers for cluster 1 and cluster 2, the changing cluster centers throughout 3 iterations, and then the final cluster centers. So let's take a look at the final cluster centers here. We can see the z-scores for depression, anxiety, and for substance use in cluster 1 and for cluster 2. If you double click on this and highlight this region, you right click, go to Create Graph, and then select Bar, it's going to insert a bar chart into the output. And you can see, based on just these two clusters, you have one set of programs where the depression and substance use score is very low, but the anxiety is slightly elevated, and another cluster where the depression and substance use are very high, and there's a slight decrease in the anxiety. So if we go down here to the ANOVA table, we can see that we have statistical significance for depression and for substance use, but we do not have it for anxiety. So this tells us that anxiety did not have a significant impact on determining which cluster a program was grouped into. And if we look down here at cluster 1 and cluster 2, we have a number of cases in each cluster. You can see it's 21 in cluster 1, so 21 that look more or less like this, and then 29 in cluster 2 that look like this, where the scores for depression and substance use are elevated. So if you wanted to divide these programs into two clusters, that's what it would look like. But let's go into classify, back to k-means cluster, and this time let's specify 3 for number of clusters. I want to see what's going to happen if we try to divide these programs into 3 clusters. And under Save, I am going to check cluster membership. Everything else remains the same. I'll click OK. You can see now it's divided the programs into 3 clusters. And for final cluster centers, I'll do the same thing. I'll double click and highlight the values, and then right click, create graph, and then bar. And we can see when we've divided it into 3 clusters, the 3 profiles look a bit different, right? We have one where there's elevated scores for each of the dependent variables, so depression, anxiety, and substance use. Not as drastically elevated as what we see in cluster 2, but they're all elevated. Then in cluster 2, anxiety is very low, but depression and substance use are quite elevated. And then in cluster 3, anxiety is decreased, but depression and substance use are greatly decreased. And let's take a look here. In this ANOVA table, we have statistical significance for all 3 of the variables. So all 3 of these dependent variables had a significant impact on determining which cluster a program would belong to. And then, as you can see, for the number of cases in each cluster, cluster 1 was the largest, so that's the one where the scores were all just slightly elevated. And then cluster 2, we had the very low anxiety along with the high depression and high substance use. There was 8 cases, and there were 18 for cluster 3, where all the scores were reduced, but depression and substance use were greatly reduced. So we have here 3 distinct clusters, and if we look at the data view, since I saved the cluster membership as a new variable in that second analysis, you can see for each program, like for 1001, you can see it's in cluster 3. 1002 is in cluster 2, 1003 in cluster 3, 4 is in 1, and so on. So all of the programs have the cluster membership here as the last variable. I hope you found this video on performing a k-means cluster analysis in SPSS to be helpful. As always, if you have any questions or concerns, feel free to contact me and I'll be happy to assist you.
K-means clustering is an unsupervised machine learning algorithm that you can use to predict subgroups from within a dataset. With k-means clustering, you usually have an idea of how many subgroups are appropriate. With the k-means model, predictions are based on 1. The number of cluster centers that are present, and 2nd, the nearest mean values between observations. Some popular use cases for k-means clustering are market price and cost modeling, customer segmentation, hedge fund classification, and insurance claim fraud detection. There are a few things you need to keep in mind when you are using the k-means model. The first thing is you always need to scale your variables before clustering your data. And second, you need to look at a scatter plot or a data table to estimate the number of cluster centers to set for the k parameters in the model. That might not make a lot of sense to you now, but I am going to show you how to do this in practice in just a few seconds. Alright, let's get some practice with the k-means method. In this demonstration, you are going to need NumPy and Pandas. So we will input those, and we are also going to be using matplotlib. But most of this demonstration relies on Sidekick sklearn. So make sure to import all of the library and all of the correct modules and packages within it. I am going to type them out now. We are going to say from sklearn.cluster, the cluster module, import k-means, and then from mpl toolkits.mplot3d, import axis3d from sklearn pre-processing module. Import scale. We are going to use that to scale our variables. And then we want to import sklearn matrix. This is going to be to evaluate our model, and we will import that as sm from sklearn import datasets. We are going to use a built-in dataset from scikit-learn, and from the matrix module we are going to import the confusion matrix in the classification report. These are what we use to evaluate the model: confusion matrix and classification report. Run that, and then we have our libraries. Let's set our plotting parameters for the data visualizations in this Jupyter notebook. And then, as you have seen earlier in the lectures, we will call the load iris function in order to load our iris dataset. That is the built-in dataset we use from scikit-learn. And next, we want to scale the data. So we will call this scale version of the iris dataset X, and we will say scale and pass in iris.data, and then let's set our target variable, which will be y, and we are going to make a data frame. So we will call the data frame constructor, and we will pass in iris.target. For our variable names, we will create an object called variable names, and that will be equal to our iris feature name. So iris.feature names, and then let's just print out the first 10 records of our X dataset. So that's what the iris dataset looks like from the inside. Now we are going to cluster this data. To do that, we need to initiate a k-means object. We will call it clustering, and we will set clustering equal to k-means, the k-means function, and we are going to pass in n clusters. This parameter tells Python how many centroids to use for the clustering. And for the iris dataset, we know that there are 3 species types of irises in their data, so we are going to say the number clusters should be equal to 3. We also need to pass in a parameter for random state. So we will say random state, and this initializes the centroids before clustering and sets the seed, so that you get the exact same results here as produced on my computer. Next, we call the fit method of the model and pass in our data set. So here is our model, and we take dot fit and we pass in X. This computes the k-means clustering, and what it has printed out here is a summary of our model with default model parameters, and then the parameters we set for n clusters and random state. Next, I am going to show you how to plot our model outputs in a scatter chart. So let's create a data frame called iris_df and going to call our data frame constructor, and we are going to pass in our iris data. Let's set the column names for the data frame. Those are sepal length, sepal width, petal length, and petal width. And let's also set a column name for out target. So we will say y.columns is equal to target, and then I run it. Now let's create a color theme for our scatter chart. So I will say color theme, and then we will make this equal to an array of color values from the matplotlib library. We will pass in the list dark gray, light salmon, and powder blue. For this data visualization, let's create a subplot that has one row and two columns. In order to do that, we will call the plt.subplot, and then we will pass in one row, two columns, and in here I am going to pass in a third parameter to specify exactly what position I want this next plot to come in at. So we are going on the first plot within our subplots. Now we will generate a scatter plot like you learned in the data visualization section in the previous lectures. We will plot our petal length along the x-axis and petal width along the y-axis. So to do that, we say plt.scatter, and we will set x and y. Make x equal to petal length, y equal to petal width. Remember that our target variable is the variable that contains the species label. There are three different types of species in the iris dataset, and we want to color our data points by their species label. To do that, we write the name of our color theme and then select the labels in our target variable. These are the actual species labels. So we will say here C is equal to color theme, and then let's select iris target, the values in our target variable. Also, let's set a size for our markers, say S equal to 50, and add a title for the chart. We will call it ground truth classification. Now we call this subplot function again, and for the third parameter, this time we pass in the value of 2 to tell Python that we want the next scatter plot to be the second of the two charts. It might generate an identical scatter plot, but this time we will color our data points according to their predicted species labels instead of their actual ones. So I am going to copy and paste this code we used here to generate the first scatter plot. But then I am going to change the target variable, and I am going to say instead we want to color our chart according to the clustering labels, the labels that were predicted by our clustering model. So we say clustering labels, clustering dot labels, and then change the title to k-means classification. Print it out. The model appears to have predicted clusters pretty accurately, except for the fact that the clusters themselves are mislabeled. That's easy to fix using NumPy's choose function. Using this function, we can easily reassign label names to predicted labels. We will say that label 0 should be changed to 2, label 1 should be changed to 0, and label 2 should be changed to 1. So we will call this relabel, and we will call the choose function np.choose, and we will say of the clustering labels, clustering.labels, we want label 0 to be changed to a 2, label 1 to be changed to a 0, and label 2 to be changed to a 1. and then we want this to be an integer data type. So we will say as type np.int64. Then let's regenerate our charts. So what I'm going to do is I'm just going to copy and paste the code we already wrote. But then instead of coloring the second chart by the clustering labels, we are going to color it by the relabel object. We will run that and it looks like a pretty good fit. It looks like the k-means model did a pretty good job of predicting the clusters. But in order to verify that quantitatively, we will use scikit-learn's classification report to score the model. To do that, I will say print and then I will call the classification report function, classification-report, and then pass in y, our target variable, and relabel our predicted values for our target variable and run that. These are some metrics that you can use to evaluate the accuracy of your results. But before looking at actual numbers, I want to explain to you that precision is a measure of the model's relevancy and recall is a measure of the model's completeness. What you are going for in machine learning is high precision and high recall. That indicates that you have highly accurate model results. So looking at the results of our model evaluation, you can see under the precision return for record 0, for all points predicted to have a 0 label, 100% of the retrieved instances were relevant. That is indicated by 1.0 here. And then for all points that were predicted to have a 1 label, 74% of the retrieved instances were relevant. Looking over at the recall metric, for all of the points that were labeled 2, 72% of the results were returned as truly relevant. Of the entire dataset, 83% of the results that were returned were truly relevant. Just remember, you are going for high precision and high recall. That wraps up things up for the k-means method. Next.